Hey everyone, it is Mr. Simons. I am going to record myself kind of teaching the lesson, and then you guys can use this to help you go through some of the problems and figure this out. And hopefully, this will be helpful. These skills problems are the ones that are in your green packet on the skills side of the sheet. This is lesson 6.3. And then the practice problems, which I'll assign to you at the end of this, will also be on the other side of that. So you will probably want a little more room to work on for some of these. So if that's the case, just use, the notes side of the page or whatever you need. You can always copy these problems down, whatever you got to do. All right, so basically the way elimination with addition and subtraction works is you are looking for the same variable to have the same coefficient or the opposite coefficient. And so by opposite coefficient, I mean, like if you've got a -3, you're looking for a 3. Or if you've got a 1, you're looking for a -1. If you've got a 5, you're looking for a -5. If you've got a -7, you're looking for a 7. That's what I mean by opposite. Same means exact same number. So if you look at problems 1 and 2, these are a little weird, but they both have each, right? They both have a variable that has the same coefficient, and then they both have variable that has opposite coefficient. And so the difference between using addition or subtraction is just that. All right, it's like one, you're adding both of the equations to each other, and I'll show you how we do that in a second to get at your answer. And the other one, you're subtracting one equation from the other one. So what I'm going to do is I'm going to start out by showing you some ones using addition, because addition is a little more straightforward. All right, and so if I'm going to use addition, you have to find ones that have the opposite coefficient. So I've got this one right here, right? I'm looking at number 1. So I've got x minus 1 equals 1 and x plus 3 equals 3. And then so what you do, and I'm going to write these down again, is I'm going to add, because I know that this y and this y are opposite of each other. You got a -1 and you got a +1 there. I'm going to add the equations together, and I'm going to add them together vertically. So I'm going to add my x's together. When I add my x's together, I get 2x. I'm going to add my y's together, and -y plus +y gives you 0 because they cancel. And then you add 1 and 3 together, and you get 4. And so what's happened is you've eliminated one of the variables now, and you've gotten it down to one variable where you can solve for it. All right, by dividing by 2. So then I get x equals 2. And then once you know that, you can plug it in the equation, one of the equations, to find the other thing. So I'll just put it in this first one. So if I plug 2 in, so 2 minus y equals 1. All right. And well, that means y would have to be, what? It would have to be 1, right? So I move y over to the other side, and then I move this 1 over here. So you'd have 2 minus 1, and you'd have 1 is equal to y. All right. So the solution for this one would be the point 2, 1. Okay. All right, let's try number 2, just to kind of give you a little more hang of it. So again, I'm going to write it down so it's a little bigger. This one, my opposite ones are my x's. All right. So when I add this together, my x's cancel out. My y's become 2y, and then 1 plus 11 is 12. So solve for y by dividing by 2, not by y. All right, so you get y is equal to 6. All right, and so now if I know y is equal to 6, if I put it in, let's put it in the second equation. Let's put it in x plus 6 equals 11. I put it in this one right here, okay? So x plus 6, that means x would have to equal 5. And so you're talking the 0.56. And so that's kind of a, you know, a quick and easy way of how addition works, all right, is that you find the variable that has the opposite coefficients of each other. So like in number 4, which I'm not going to do, but just to point it out, in number 4, like you could do addition because you have negative x and positive x. So you could add those up and then you can solve for it. Now, there's a lot of times when that doesn't necessarily work because you'll get something that has this exact same coefficient, but it's not opposite from each other. And so we use a different technique then when that happens. And so I'm going to go over that and show that to you right now. Okay, once I clean this up here. All right, so like if you look at number 3, we have x plus 4y equals 11, and you have x minus 6y equals 11. And so what we're going to do is we're going to use subtraction this time. So what that means is you're going to subtract one of the equations from the other one. All right, and it really doesn't matter which one you do. I guess it just depends on whether or not you like positive or negative numbers to work with. I'm always going to subtract pretty much the bottom equation from the top one in these cases. So if you think about what you do when you subtract something, so like when you subtract 7 and 4, right? Basically what you're doing is you're making 4 negative, right? And then you go 7 minus 4, which is the same as 7 plus negative 4, and you get 3. So it's the same thing when you do subtraction. So pretty much what you're doing is you're going through the bottom equation and you're changing the sign and everything. So I'm taking this and I'm making this negative, I'm making this positive, and I'm making this negative. All right. And so then what happens is, and then you just add it, right? So you go x, because that kind of is what subtraction is, right? So x minus x gives you 0, right? So that gets rid of that. 4y and 6y give you 10y. And then 11 minus 11, or 11 plus negative 11 gives you 0. So then you would get y equals 0. And then we can put that in either one of these. So you go x plus 4 times 0 equals 11. That gets rid of that. And then you get x equals 11. So my solution is the point 11, 0 for number 3. So let's look at another one that's going to be a little more straightforward. Let's try number 5 next. Okay, so go to number 5. I'm going to clean this up a little bit. All right. So number 5, you've got 3x plus 4y equals 19. You got 3x plus 6y equals 33. All right, so I'm gonna do that thing where I make the bottom all negative. Okay, so it's like you're applying a -1 to everything in here. So this becomes negative, this becomes negative, and this becomes negative. All right, so 3x and minus 3x equals 0. 4y minus 6y gives you -2y. And 19 minus 33 gives you -14. All right, and then it's -2y equals -14, so you divide both sides by -2. You get y equals 7. And then I'm going to put 7 in for y in that top equation, I think. It doesn't really matter which one you use. I always go for which one I think is going to look easiest. So 28, 19, 3x. And then subtract 28 from both sides. So this gives you -9, 3x. So then if you divide both by 3, you would get x is equal to -3. And so your solution then is the point -3, and then here's your y value is 7. All right. And then you could put that in this lower one and see if it works. All right, to just check your work. Okay, so let's just continue to do a few more of these, and then I think this will hopefully start to make some sense to you guys. All right. So let me try using this. This is probably a little easier. Delete. Oh yeah, much easier. Make this bigger. All right, so let's look at number 7. Let's do 7. All right, so 7, you have 3x plus 4y equals 2, and then you have 4x minus 4y equals 12. And so this one, my y's are opposite of each other. So this one's ready to go, and I can just add this one together. Okay, so 3x and 4x give me 7x. My y's cancel. 2 and 12 give you 14. So that means x is equal to 2 because I divided both sides by 7. Right, I'm just not writing it down so that we're keeping things a little neater. And then I'm going to put 2 in that top equation. So I'm going to go 3 times 2 plus 4y equals 2. So I got 6 plus 4y equals 2. Move the 6 to the other side. So you have 2 minus 6. So you have 4y equals -4. All right, and then divide both by 4. You get y is equal to -1. So you get 2, -1 as your solution for that one. And then I'm putting it in this bottom one, and it looks like it works because 4 times 2 is 8. And then -4 times -1 is +4, and 8 plus 4 is 12. So that looks good. All right, let's try. Let's try 9. Let's just keep going down there. All right, so 9, you got 2x minus 3y equals 9. And then you get -5x minus 3y equals 30. So because my y's have the same number in front of them, but it's they're not opposite, I'm going to have to do that trick on the bottom one where I change the sign on all of them. So this is going to become +5x, this is going to become +3y, and this is going to become -30. All right, so you're just basically you're multiplying that whole thing by -1. So you're changing the sign on each item. So you get 2x and 5x gives you 7x. And then you have -30 and 9, which gives you -21. Divide both by 7. You get x is equal to -3. And then if I put that into that top equation, so 2 times -3 minus 3y equals 9. It's -6 minus 3y equals 9. Add 6. I apologize if I'm skipping some steps from time to time, but I think you guys should be at a point where you should know how to do most of this. All right, y equals -5. So you get the point -3, -5. I'm going to just, in my head, plug it into the bottom equation. So -5 times -3 gives me 15. -3 times -5 gives me +15. And 15 plus 15 is 30. So works well. So that's pretty much how these work, is that if you've got them where they already have the opposite coefficients of each other, you can just add them straight up, and you're always doing it vertically. You solve for one variable, and then you plug your answer in for that into one of the other equations to find the other one. So in that sense, it's similar to substitution. And then if they are, you know, and now let's, we'll do one more example. Let's do number 15, okay? So number 15, my 7x's are the same, right? I've got 7x plus 4y equals 2, and I've got 7x plus 2y equals 8. So I'm going to make this bottom one, I'm going to apply this negative sign to everything in there. So when I do that, this becomes negative, this becomes negative, this becomes negative, right? And I applied that so I could get it out of there. So 7x and negative 7x cancels it. 4y minus 2y gives you positive 2y. And then 2 minus 8 gives you negative 6. And that means that we divide both sides by 2, that y is equal to negative 3. So now, let's first of all, let's make some room. Let's put negative 3 in that, I don't know, it doesn't matter. They're going to be ugly no matter what. Let's put it in that top equation. So you have 7x plus 4 times negative 3 equals 2. So you get negative 12 equals 2, 7x. We're going to add 12 to both sides. So that's starting to neaten up. 7x equals 14, which means x equals 2. So my solution would be 2, negative 3. Let's try this in the bottom equation now and just see if it works. 7 times 2 is 14. And then 2 times negative 3 is negative 6. So 14 minus 6 is 8. So again, you guys know I'm a big proponent of checking my answers for everything. So I hope this helps you guys with follow through with this. I'll also have the book packet available on the Google Classroom lesson for this. And then for the homework, let's see if I can move some things around here and see where the homework is. Let's have you guys just do every other odd again. So we'll do 1, 5, 9, 13, and 17. And don't let 17 throw you off because of the fractions. Because if you look at it, you see that your negative 1/3 and your 1/3 are opposites of each other. So you're just going to add those together. And so really the hardest thing you have to do is to add negative 4/3. Actually, with now that I'm looking at this, I want you guys to skip 17. All right, so you're going to do all the other ones. And instead of doing 17, I want you to do 18 because 17 is missing that y, and I don't know if it's supposed to be or not. So you're going to do, again, you're going to do 1, 5, 9, 13, and 18. Okay, and we'll just leave it at that. All right, we won't do any word problems for right now. I'll go through a couple of those with you once I'm back. So sorry, this is kind of a not ideal way to learn, but thanks for putting up with it. And I look forward to working in person with you guys again soon. If you have any questions about this, even though I'm technically not working this week, you can email me and I'll see if there's, if it's a quick question or something, I'll see if I can help you. All right. So good luck with these.